Okay, so we're going to try an experiment with Tinkercad here to see if we can do this through the Tinkercad classrooms. So we are going to attempt to do this, which is lab number 3. We're going to do lab number 3, part A. So if this was being done in the regular lab for this class, basically students would get this lab in PDF form. They would have to read this. They would read the part in the book as well. There is a video that goes along with this, which they could watch on YouTube. If they go to the Darren Holmes on YouTube, they can find these videos here. I'll show you where that is. Go to the Darren Holmes and look up under the playlists. Here under the digital labs, and then this one is digital lab number 3. And this is like an hour-long walkthrough of everything for this lab. And this will show you how to do everything you need to do for setting up your breadboard and walking through and wiring up these individual experiments and how to answer all the questions that go along with this lab as well. So students might be able to do this this semester, but what they can do is they should be able to do this entire thing through Tinkercad as well. So that's what we want to see if they can do here. So we're going to try to do basically this whole thing here in Tinkercad and get the same results. So I want their breadboard to look basically like this in the end, and to do the same experiments and create these same truth tables. So you could use this PDF for reference, you could use this video for reference, and you can do all these things. So in Tinkercad, if you can get logged in, you should be able to go in with the link that I sent for this class, and we are going to create a new circuit. I'm going to say create new circuit, and I am going to open up this here just as a separate window. Set this down in the corner. So we're going to create this circuit right here. So this is basically a single chip. It's a 74LS08 chip, and we are going to basically use 2 switches, so 2 dip switches and 1 LED to verify this truth table. It will basically look like this. That here, so that's what we're going to create in Tinkercad. So let's look how we're going to do that. So our stuff that we need, we are going to need under circuits, we're going to need a breadboard, a power source, which is the power supply. You're going to get out of the basic and go to the all. Set down here for power supply. This one here. We'll use that. We can do this simply, or we can do it exactly like they do in the lab. We'll try to make it exactly like in the lab. I'm just going to bring in all the components first and I'll wire them together. The other thing we're going to need, an LED, two of these diodes. We're going to use the diode, not the Zener diode. So diode, and then another diode. 3 different resistors altogether. We'll bring those in, and we'll change the values of them later. And then we need our chips. And when we get down into the chips here, type and that is going to be, these are all HC chips, but that's okay. This one here says quad and gate. So 74HC08, we're going to use that. So this should be everything I believe that we need. So if we bring up our diagram again, you'll look how this is built in that picture as well. So the way we're going to build all of our circuits, we have a power supply, which we're going to set the voltage on this to 6 volts. That is the same. Our circuits all run on 5 volts, but if we run 6 volts out of here, the diodes knock it down to about 5. And you will see that if you're running off the batteries actually produce 6 volts. 4 batteries at 1.5 volts each. So we need to go from, I'm going to make this smaller so I can actually get the, both on the same screen at the same time here. So we go from power supply through the diodes and then to the buses on the breadboard. Let's bring our diodes over here. You'll notice these silver lines on the diodes. That goes on the negative side of the diode. So basically power comes in through the anode, exits through the cathode. So you'll see on this one here, if we go with our positive wire here, connect that there. And with our negative wire, it actually needs to go to this side of it. So we're going to take this guy here and using this button, we're going to spin that around. And that is the way these diodes will work. We're going to do that. Now this cathode here, this is basically our positive power coming in. This needs to go to this plus bus here. So I'm going to draw a wire here. I'm going to bend it around. That. This one here I'm going to draw like that, kind of bend it around, touch into there. You'll see when I touch here, all of those terminals are connected together. All of these terminals are connected together, also on the breadboard. All these individual little rows are connected together, and these guys down here are connected together. One thing that's always done wrong on these breadboards, this bus here, this negative bus, should be the same as this negative bus, but they're not internally connected, so you actually need to put a connection out here. To do that, students always forget to do that. So we're just going to put that wire out here to connect that up. And another thing we will do is we're going to color code our wires. You don't have to do this, but it just makes things easier. Anything that is just completely our positive wiring, we're going to make that red. So red basically means that is our 5 volts. Just to make things easier to understand. And we're going to use black for our negative or 0 volts. We'll also use blue for that. We're going to use red and black as our 2 color schemes there. Alright, so that is basically wiring up our board. If we start simulation right now, you'll see that we get 6 volts here. We now have 6 volts on here. We have to have 0 volts on here. Alright, so that's that so far. Oh, the other things we need a dip switch on here. Let's grab a 4-position dip switch. And let's start dropping things on here. So the dip switch is going to plug in, let's put it in over here. And you can see we have a switch. We have power coming in through 4 kilo ohm resistors. In the lab, we use a SIP resistor, which basically is a package of resistors. We don't have that in our lab kit here in Tinkercad. So we are going to use individual resistors, but we're going to change the resistance on these. So 4.7 kilo ohms. You'll see the color code change on that when we do this. 4.7 kilo ohms. We're going to put these here between power and that's switch 1, between power and switch 2. That's basically here, 5 volts to switch 1, 5 volts to switch 2. Then we need to put a wire between switch 1 and switch 2 and ground. So let's connect that. We're going to go down to this bus here. Put a wire there, put a wire there. We're going to make those black because they touch our negative. And then we have our chip, our 08 chip. We're going to drop that in here. Our chip's always going in the middle here. So basically all of these holes right here are connected to pin 1 of the chip. All these ones are connected to pin 2, so we have lots of options where to plug things in there. You have to remember with chips, there's a power pin and a ground pin on the chip. You have to refer back to the diagrams. If you look at the diagrams here, you'll see VCC is always on pin 14 for this chip. And you can tell over here, pin 7 is always the negative. And you can tell this wire here is what those represent. So this is pin 7, going to the negative. Pin 14 going to the positive. So that will actually power the chip. And then we want to have this LED. So we go from output to LED to resistor to ground. So this resistor here, this is going to be 330 ohms. So 330 ohm. Orange, orange, brown. So that connects over here. Now we've got to make sure with this LED, this is kind of tricky. That's the anode, this is the cathode. If you put this in backwards, it won't work. So cathode is the, anode is the positive, cathode is the negative. So if we put this here, we have to remember that this is what connects to our negative side. Positive has to come in here. So this is where our output is going to go. And if we go back to our diagram of our chip, again, it lays out the diagram here. You can tell how this is wired, or the easier way to do this is actually input 1A, input 1B, output 1. So pins 1, 2, and 3 are the pins we're going to use. So our output comes off of pin 3. And we can put that over here. Let's go orange for our output wire. And then our 2 input wires are going to come from here. This is controlled by the switch. So we need to go to pins 1 and pins 2. Something like that. We'll make that a purple wire and a green wire. I'm going to do something like that. So what we should see now, when I simulate this, I now have an LED that comes on, and as I turn these switches, that position there gives me LED on, anything else gives me LED off. So what this represents, switches in the down position represent a logic 1 for each of these. So this is a logic Input 1 is a logic 1, input 2 is a logic 1. That gives me a logic 1 as an output, as indicated by the LED is on. That is a 0, 1, gives me a 0 on the output. That is a 0, 0, which gives me a 0 on the output. That is a 1, 0, which gives me a 0 on the output. That is a 1, 1, which gives me a 1 on the output. If you want to verify how this actually works, one other thing we can do. Let's put a multimeter on here. I'm just going to connect this to the negative. I'll just connect this to the positive on here, and then when I run this, you'll see this position here gives me 4.82 volts. That's basically a logic 1. If I switch to here, that gives me 0 volts, which is a logic 0. So that's the logic 0 position. That is the logic 1 position. Okay. So what we have now, this is basically the completed lab number 3A. So what you would want to do at this point is put your name, oh, where's my name? And where'd my name go? See where I can put my name in here. I lost it in the naming here. Okay, this messed up when I'm trying to name it. But what you would want to do is put your name on this. You would want to name it as lab number 3A or something to that effect. Save it and submit it to the, and save it, and then I should be able to see it in the classroom. So complete this and then save it with lab 3A as the name, and I want to see if I can find it in the classroom. Okay, so that is the task. I want to see if this works. Okay, thank you, and yeah, let's see if this works out. Okay, thanks.